Yeah. Geometric sequences. Geometric sequences. So last couple of lessons we've been working with arithmetic sequences. What we understand by an arithmetic sequence is that it increases by the same amount every time. So we're going to look at a new type of sequences. Let's have a bit of an investigation to begin with. So this is for you guys. Here in the investigation, what I'd like you to do in question 1 is to look at each sequence, try and figure out what the next few numbers in the sequence are and write them down. And then if you can complete this table, if you notice from this sequence, we have the numbers 2, 4, and 8. So we take the second term in the sequence, divide it by the first. We take 4, we divide it by 2, we get 2. We take the third term, which is 8, divided by the second term, we also get 2. So have a look at this investigation here. I'll give you 10 minutes for this. Work together with your table partners. And I'll pause the video for a few minutes. No, that's not paused. I have to go here. Okay, so what are the next numbers? We get 32, 64, 128, 256. Sequence B. What comes after 27?
81.
Is it negative 81?
Yeah.
So
positive 243.
And then 243.
Negative 729.
I'll end here. Negative 729, is it?
Yeah.
What we're going here is multiplying by minus 3 each time. We're going up by multiplying by minus 3 each time. So in C, what is the next one at the end of the sequence going to be?
It's going to be 3 over 8.
It's going to be 3 over 8.
And then it's going to be 3 over 16.
3 over 16. And then going backwards.
It's going to be negative 12. I mean, to the second.
Oh, they're all negative. Negative 12, negative 24. So what's happening here on this one?
It's getting divided by 2.
No, it's getting multiplied by
1/2.
yeah.
And then to go back, you multiply by the 2.
We're multiplying by a half each time.
Yeah.
But to go backwards, how do we go backwards? We multiply by 2.
Yeah.
The reciprocal. Multiply by the reciprocal. You can use division. Obviously, it's going to work with division on this, but it's going to be good for our understanding of the concept to always use multiplication. So if you want to divide by 2, multiply by a half. And to go backwards, multiply by the reciprocal. So which factor is bringing us forward here?
5.
We're multiplying by 5. So to go backwards, what do we multiply by?
Negative
1
1.
over 5.
1 over 5. We don't add a negative to go backwards. We add a negative if it alternates. Positive, negative, positive, negative, positive, negative. So if we're coming backwards, we're going to get 1 over 5. Oops. 1 over 25. 1 over 125. And what is it? 525?
That's
Sounds good.
And then our divisions. So if we take the second term and we divide it by the first in sequence B, we are taking the second term, which is 3, dividing it by the first, we get minus 3. If we take the third term, minus 9, divide it by the second, we get minus 3. If we take the fourth term, 27, divide it by the third term, we get minus 3. Remember, we were multiplying by minus 3. So this is a technique for finding that number. I'm going to leave that there. What do we notice about the ratio of consecutive terms for each sequence? What we notice is it's the same. The ratio for consecutive terms is always the same for a geometric sequence. And this is the technique we use to show that a sequence is geometrical. If you have a question where you're asked to show that so-and-so is a geometrical sequence, you need 3 pairs of consecutive terms and show that the ratio is the same for all 3 pairs. If you just do it for 1 pair, you're only, any set of numbers, any sequence, 1 pair will give you a ratio of some kind, but you're not showing anything there. If you show it with 2 pairs and it's the same, you're going in the right direction, but you can get quite a few sequences that will have a repetition at one point, but 3 times is unlikely. All right, so what we see is the first term in the geometric sequence is called U1, the common ratio. So in an arithmetic sequence, we had a common difference because we added. In a geometric sequence, we have a common ratio because we multiply by it. So this common ratio is called R. We can find R by taking consecutive terms such as U2 and dividing it by U1. What is the general form for this?
So the R equals UN over UN minus 1.
UN over UN minus 1. This formula is not in the formula sheet. It is a very useful formula. You need to make sure you know this formula by heart.
Yeah, more here.
It comes from a conceptual understanding of how the sequence works, which comes from that investigation we just did. Hence the point in the investigation.
That's
It's the idea that the ratio of consecutive terms is the common ratio. Next up, if we take U1, U1 is equal to U1. U2 is created by taking U1 and multiplying by the common ratio. U3 is taken by taking U2 and multiplying by the common ratio. But if you substitute this formula into for U2, then we can go from U3 to so we can go from U1 here up to U3 by multiplying by 2 lots of the common ratio.
Oh.
To get U4, we can take U1 and multiply by 3 lots of the common ratio. How do we get to U5 from U1?
We multiply by 4.
4 lots of the common ratio. Let's have somebody else fresh. How do we get to U6 from U1?
U1 times
R
R to the
five.
So,
U1 times R to the R5.
okay. So, general, how do we get to the nth term coming from U1?
U1
Maya.
U1 times R to the R n minus 1.
Why is it n minus 1 in this formula?
It's the term, not the value of the term. If that makes sense.
I like to think of it as that we don't need to multiply by r to get from U1 to stay on U1.
Yeah, that
We only need it to move forward 1 step. So you're always moving forward 1 less step than the nth term, so to speak. So this is our general formula. This is how it looks in the formula sheet. Open your formula booklets now and have a look and find the formula in the formula booklets.
I do have, I've got the folder and then first was at my desk.
So you find it? Where is it?
Yeah.
Where is it? Point to it.
Here.
No. No.
And
Try hard. Where is it in the formula booklet? Yeah. Let's point to it. Yeah. Where is it in the formula booklet?
It's here.
Yeah. Okay. So to check whether a sequence is so this first block, in this first block, to check whether a sequence is geometric, find the ratio of pairs. I suggest 3 consecutive terms. If the ratio is constant, then then it is the common ratio, and the sequence is geometric. So this is the show that type questions. Let's do some easy ones. I'll do the first one for you. So number 1. Sorry. Let's do this is 1A, part I. What is the first term in the geometric sequence given here? U1 is equal to 2. What is the common ratio? The common ratio R is going to be given by 6 over 2, which is 3. Now in this case, notice I've only done it once. I'm always saying do it 3 times to prove that it's a common geometric sequence. I've only done it once because we don't need to prove this is a geometric sequence.
Exactly what
It says in the question it's a geometric sequence. So then you only need to do it once. We can assume it's geometric from that point. Lastly, we need to find out what U10 is. So U10 is equal to U1 multiplied by R to the 9. So that is 2 times 3 to the 9. We need a calculator for that one. We need 2 times 3 to the power of 9. 39366. 39366. Okay, I shall pause the video now. Have a go at B and C like that for yourself to practice this. All right, so let's have a look at the answers. So for sequence B, what is U1? -3. What is R? Negative.
Yeah, but that's, we have.
6 over -3, -2. That's correct. I like to have the formula, not the method points. And then for, how do we calculate U10? We want U1 times R. How many lots of R do we need? 9 lots.
9.
So U1 is -3 times -2 to the 9. What do we get for this?
1,536.
1,536. Okay. So calculate. Use your formula now on this one, and calculate what U13 is. Use your calculator now, everybody. Calculate what U13 is.
Sir, why is it not turning on? I can't tell because it's not mine, it's my friend. Is it dead? I tried to reset it.
No, there's. Oh, -3 something. Yeah, I got a negative.
Okay, half of you got a positive answer, half of you get a negative answer. Figure out who's correct.
Negative.
Christian.
No, positive.
It's the safest one.
Christian, which one is correct?
He's right, guys.
Positive, because negative is negative, so.
Thank you, sir.
We should have. Sorry. We should have a negative answer.
Oh, it's negative.
So U13
I had money running on you.
is going to be -3 times -2 to the 12. Now, I can tell whether it's going to be positive or negative. Look here. This 12 is an even number, which means that is going to get cancelled and become positive. Sorry, the minus sign in here is going to get cancelled because there's an even amount of pairs creating in the multiplication. So this will become positive and this will be negative. So the result has to be negative. Now let's have a look at your calculator usage. It's all down to how you put it into your calculator. So for this one, what was the numbers? -3 and -2. We need, which way around? -3. We need -3 multiplied. If you have common ratio, which is negative, always put it inside a bracket. Otherwise, you will make the mistake. So we want it up to the 12 to get the 13th term. This should be the answer. Those of you got it wrong did this. Because it raises it to the power of 12 first, then it puts the minus sign on the 2, then it does the multiply by -3, giving you a positive answer.
Okay.
If the common ratio is negative, always put it inside a bracket. Time for the last one, C. U1 is 16. How do we calculate the common ratio? 8 over 16. And that gives us a half. How do we calculate U10? We want U1 times R to the 9.
16 times, half times 9.
To the 9.
And what do we get as our answer?
Sir, it turned on and it shut down again.
it back if you want.
When we didn't test on the back, we go so quick. What did we get as the answer?
1/32.
That sounds right. 1/32.
32.
1/30. Oh. I'm pretty sure if you check the video evidence, I said 1/32. My hand just wrote something else.
So yeah, the half would be as well as 2 points. It's exactly how this is. In my head, I say something and then it just comes out wrong.
It doesn't feel wrong, it feels right. Let me show you. So 16 is 2 to the 4. 1/32 is 1/2 to the 5. So we see the 5 and the 4 that make the 9. So 2 to the 9, that would cancel 4 of them with the 5. This isn't quite right. Let me prove by mathematical language. 1/2 to the 9 is equal to 1/2 to the 5. There we go. And you see that 4 minus 9 gives minus 5. Okay, I'm going to do these ones for you. So Caroline is starting a new job. She earns $48,000 for her first year. Her salary increases by 5% each year. Show that Caroline's annual salary follows a geometric sequence and state the common ratio. Calculate how much she will have in the 50. So we got 3 questions here. Let's tackle the first question. Show that it follows a geometric sequence. How do we do this? We need consecutive terms. So we have to generate those consecutive terms. Our first term, U1 is equal to 48,000. Let's just do it like this. 48,000, we'll show it as a sequence. What's the next term going to be?
Plus 5%.
How do we add 5%?
Times 1.05.
So we want 48,000. Calculate on your calculator now.
15,400.
Yeah, 50,000.
So the minor is going to be on arithmetic sequences, right?
Both.
Oh.
Minus 1.05.
52,000.
0.5.
You only need 3, right?
3 pairs.
Mm.
So you need 4.
Okay, so 52,920. And then
52,920.
And then 55566.
55666.
Oh, I got 555.
Oh. 55566. So we got enough pairs. Let's take consecutive pairs. Let's take 50/400 divided by 48,000. Put it into our calculators. Oh, look, we get 1.05. Let's take 52,920 divided by 5,400. Oh, look, we get 1.05. And then put this last one into your calculator. Divide it by this one.
I have a question. Isn't it like, can we say that it's a geometric sequence by the wording of the equation instead of, the wording of the question instead of?
This is the standard procedure I wish to teach at this point in the course.
Because it says it increases, because how it shows it in the question, shows it
Yeah,
increases not by a set amount.
Obviously, you see that by how you just generated the 3 terms. So to generate the sequence on the calculator, the easiest thing to do is to type in 48,000 and then press multiply by 1.05. This will let you just keep multiplying by 1.05 and generating all the terms in the sequence. So if you start by just typing the number in, and then when you do times by 1.05, you times in the previous answer. So you're always timesing by the previous answer, and you get the whole sequence fairly quickly this way. But anyway, this is how this implies. So common ratio is the same, or I think ratio is common to all terms. No. All consecutive terms. Which implies sequence is geometric. That looks like one of those sort of interpretation questions or those reasoning questions that are likely to come up on any upcoming minors or majors.
Is that a hint for the next minor?
Yes.
Look at the wording carefully. Ratio is common to all consecutive terms, rich in mathematical language. This implies the sequence is geometric.
If we don't say
If we don't,
consecutive,
Yeah, I don't see anyone writing any notes down at this point.
if we,
State the common ratio. That's our next question. State the common ratio. R equals 1.05. Lastly, calculate how much you will earn in the 5th year. So let's use the formula for this one. So, in the 5th year, do we want the 4th, 5th, or 6th term in the sequence?
5th year.
the 5th, wait, okay, after.
Think it through. Read the question again. Think about the sequence. In the 5th year, how much will she get paid in the calculate how much she will earn her 5th year at work.
So we use it for
48,000 times 1.05 to the power of, what is it?
Oh, I remember this one. This one was the
Or
trick
to the
one.
power of 4, but is it?
It was for me at least. I think it is a bit.
What did she earn in her first year?
48.
40,000.
What did she earn in her second year?
50,000. Oh, are we doing the sum?
No, we're not. So in the first year, she earns U1. In the second year, she earns U2. So in the 5th year, she earns U5. So this one is 48,000 multiplied by 1.05 to the 4. Put that into your calculator, what do we
Oh,
get?
no, wait, it wasn't this one, it was the other one that confused me with the next one, yeah. Sorry, my
Put
brain's
this
all-
into your calculator, what do we get?
That's correct. We get.
I'm so tired today, I can't think about it.
What do we get?
So cheap.
Click, click, click with your little fingers. Pretend you're texting.
5.8. That's really good.
So why are we getting the E?
8. I don't know. 48.
Because you're putting the parentheses wrong.
1.05. Oh, I bet,
58,300.
5.
No, but it's still coming E.
Still coming. I think it 5.83.
You could calculate the difference.
Please turn them off.
Okay. So 58,344.30. So in an exam, you should always answer with 3 significant figures.
Yeah.
Unless
Yeah.
they ask you to answer it in a particular way, so 2 decimal places or standard for this or that. Unless, there's one final unless, if it's currency. If it's currency, the normal standard is to answer with 2 decimal places. So even though this ends in 3, I answer it as 0.30 for this answer. Answer currency with 2 decimal places.
So will we mark down if we don't answer with 2 decimal places for currency questions?
Ooh, what the hell did I do that?
Oh, wow.
That was funny. Let me duplicate this.
Oh, sorry, you're still recording, by the way?
I am?
Oh.
Okay, so question 3. The third term in a positive geometric sequence is 63. The fifth term is 567. Find the common ratio in the first term. This is a really common exam style question, and I want to do this one. So if we are wanting to, this one is the fifth term, so this is U5. This is the third term, this is U3. So if we want to go from U5 to U3, from U3 to U5, how many lots of the common ratio do we need to multiply by? Chris, you keep quiet. How many lots of the common ratio to move up 2 places?
2.
So think about how many places in the sequence you're moving up. You're moving up 2 places. We're going from, here would be our sequence. We're going from U3 to U4 to U5. R. So we'll multiply by R squared. We can put this into our formula. We've got 5, 6, 7. It's going to be 63 multiplied by R squared. Solve this equation now for yourself. Have you done any sort of attempt at looking at what the settings are?
Yes,
Yeah, but you change it then. Because you're in float 4. You move to float 3. I mean float. Yes. If you have a float which is less than the number of significant figures being given, it will subtract it and give you an E. So to get rid of the E, you put it into just float. And you will multiply. Document 7.2. I'm still showing you how to do this.
It's on my phone.
No, I'm still showing you how to do this at least 30 times. No recognition.
Oh, it's on
3 days ago.
No.
3 days ago.
Okay. All right, what do we get as our answer? R is equal to
Dress.
3. How did we solve?
AISL.
Did you find another solution?
No.
Why not? It's NSolve. NSolve will give you the closest solution to 0. There could always be another solution. It's a quadratic equation. It's very likely to have another solution. Find it now.
The common 0.
Find it now.
No, 5, 6, 7.
All find it with your own calculator. All see if you can find this other solution. Don't shout it out once you found it. Tell me when you found it. Well, you'll know. So you just tell me when you found it.
There's only one.
Think wider.
So how do we find the second?
You have to think.
It's something to.
No solution found.
Let's go.
It's 2. No,
it's
it's also to 0, so it's not right.
Yeah, no.
Doesn't it look like the headphones
All right. So you got to this point. One solution. Is there any more solutions? Let's NSolve our way to the answer. You love NSolve. So we say, well, let's have a look at, is there a solution bigger than 3? No solution found.
The solution is smaller than 3? But no, because it's closest to 0. Yes. Closest to
So if 3 is the positive number closest to 0, there could be something in the other direction. So if we go from minus 1,000 up to 0, if we solve from minus 1,000 up to 0, we might find another solution. Negative 3.
Oh yeah, because to find it, you're taking the root of it, so that it could be -3.
So one of the dangers of NSolve is you've got to remember to look around for the other solutions. If you do this, it will serve you fine. You can always just rearrange this to 567 over 63,
Yeah, that's what I did.
which is 9 is equal to r squared, which implies that r is equal to plus minus the square root of 9, which is plus minus 3. You can solve algebra. We get two solutions. However, we don't need both. If we look at the question, it says it's a positive geometric sequence. So you have two possible scenarios on this one. Let's have a look at them. So if we took, where am I? I'm here. If we took 63 and we multiply it by 3, we get 189. So we know that U3 is 63. U4 we don't know. U5, 5, 6, 7. We know this to be true. So 189 would make a positive sequence. There is an alternative sequence with an alternating sequence. We'd still have these here. We could have an alternating sequence with minus 189 here. This would come from r being minus 3. I want to show this so you sort of understand how there's two possible ones. When the two are apart, you don't know whether it's an alternating sequence or not.
Yeah.
If it's a positive sequence, then it means that r has to be 3. If it's an alternating sequence, r has to be minus 3. This would be a good question for a quiz. If it doesn't say, then you have to find two solutions. There's two possibilities for U4 that could be found. Okay?
So can you upload it with the?
Mr. Farmer. We like Mr. Farmer. He buys machinery and makes us food. Mr. Farmer buys machinery for 25,000. The machinery depreciates at a rate of 8% per annum. Fine. So my first question: what is U1?
25,000.
No, this was the one that got me.
No,
It's not.
he's correct.
Wait, is it not?
U1
Come on.
equals
I
25,000.
thought it's U0.
What is R?
0.9.
0.3.
1 minus 8. 1 minus 8 is 0.
1 minus 0.8, you always say.
No,
It's
it's
so business like
point
it's
nine two. It's 0.92.
You
R
have to multiply with
R is equal to 100% minus 8%,
Which is 0.9.
which in decimal is 1.00 minus 0.08. It is 0.92. This is our R value. We need to find the value after 5 years. Do we want the 4th term in the sequence, the 5th term in the sequence, or the 6th term?
You want the 6th term.
Wait, why?
Because you're considering year 1 to be 25,000.
Let's have a look. Let's have a look. This one is a bit trickier.
Because like U0 should be 25,000 because that's the initial value.
So in our geometric sequence, it starts off here at 25,000. So here it's 25,000. This is when time is 0. This is U1, the first term in the sequence, when time is 0. After 1 year, we will have the second term in the sequence, and it will go down. After 2 years, we will have U3. So after 5, let's put in the other one, 3 and 4, we get U4, U5. We want U6. We want U6 in this one, don't we?
Yeah.
This one's a little trickier because of that. So after 5 years, it's equal to U6, which is 25,000 multiplied by 0.92 to the power of what?
To the power of 5.
To the power of 5. Put it into your calculators now. What value do we get?
$16,477.04. Because like zero is more. Yeah, I know, like the cumulative depreciation. We'll change the dates, right? When you do the
What did you get?
16,477 point.
Yeah, 16,177.03808.
Oh, I'm using 48,000 in the last question. I'm like, oh, I'm miles out. Okay, 25,000. There we go. Right. 16,477.0. How much?
4.
Ooh,
I learned so.
we'll see.
Years ago, I told you.
B. How many years before Mr. Farmer's machinery is worth half its original? How do we calculate half the original?
You divide by 2, so it's 12,500.
Watch. We're going to have a half times 25,000. That will give us.
We can do the thingy, right?
If the thing is the thing I'm thinking of, then it's the
Yes.
thing we want to do. If it's not the thingy I'm thinking of, then it's definitely not the thing we want to do.
You do the thingy.
Okay, that would give us 12,500, wouldn't it?
Yes.
Sure, sure.
So the formula we want is 25,000 times 0.92
Yeah.
to the x. Is it?
Equals 12,500.
And then you just like
And then it's all-
No. With this type of thing, if we're halving the original amount, we can cancel these two, because they appear on both sides. So we can come down to a simpler equation, 0.92 to the x. This is an exponential function, they'll only give you one answer. And solve it now.
If you wrote 12,500 equals that way.
If you wrote 12,500, you'd still get the right answer. This is just a little smarter.
8.3, meaning we would reach there at the 9th term.
This
No,
gives,
this is how many years? So 8.31.
Yeah.
this gives us 8.31. Now, with this type of question, reread the question very carefully. How many years is it before Mr. Farmer's machinery is worth half? It doesn't have, watch for words like less than half. Watch for words like less than half. And also think through other ideas. Now, if a bank is paying you interest every year, they pay you once every year. Or if your salary, like in the previous question, that's a good one. If your salary increases, does it increase every month?
No.
It increases once per year. But if Mr. Farmer sold his machinery after 6 months, would it have gone down?
Yeah.
If he sells it after 9, would it have gone down more?
Yeah.
No, because it depreciates per year.
No, it doesn't.
Oh, no, it depreciates during the year. Yeah, time is constant.
Yeah, think about the
It's not
situation in
increments.
reality. If you were offered a car which was 3.5 years old and a car that was 3 years old, the same car and everything, the one that was 3 years old is worth more to you than the one that's 3.5 years
Yeah.
old. There are other factors, obviously, in buying a car and stuff. So in this setting, it's a continuous depreciation. So we're going to say 8.31 years. It's not something that is imposed unnaturally. It's something that's sort of organic in that what people view the value to be of this stuff.
So you don't have to round it?
We don't have to round this one. So with these type of questions, read the question carefully once you finish solving. Think, am I rounding up? Am I rounding? Am I rounding down? Am I writing an inequality? Look for small words like less than, it's worth less than its half the original value. And then you would have an inequality. And then also think about the situation. Is this something, a process that is occurring at periodic times, or is it a continuous process like bacterial growth or population growth? All right, where are we up to now? We are, I think, finished for today. So, homework for today is exercise 10A and 10B from 462 to 466. We are done.